Hello everyone, this is Ihsan Sarfaraz and welcome to today's lecture on data encoding and data rates. First, let's talk about data encoding. In communication, there is a sender and a receiver, and something in between them that carries the message, called a medium. Now, if I sent you a letter, the medium would be paper using ink. If I'm talking to you in the same room, the medium is the air using sound waves. Now, somehow, the information that is being sent needs to be represented on the medium. We call this encoding. Encoding is the process of converting data from one form to another required form. Now, once the encoded message has been delivered over and transmitted over the medium, then the receiver needs some way of taking the information off of the medium and understanding it. We call this decoding. One of the best examples of encoding comes from the era before the outbreak of the internet, with the advent of Morse code. Now, Morse code is an encoding scheme that encodes text characters as standardized sequences of two different signal durations, called dots and dashes. Now think back to the Morse code example in class, or the example shown here. Let's consider the sender wants to send a message, tan fins. Now, the dots and dashes that you're seeing underneath the message is the code. So when you change the English letters into dots and dashes, you are encoding it into Morse code. Then when the receiver turns the dots and dashes back into the letters, they are decoding the message. For successful communication, the sender and receiver need to be using the same code. And this is where standardization comes in. A standard is when there is a uniform, widely accepted way of doing something. Morse code is one standard of data encoding. Another common encoding method is called the ASCII code, which assigns a unique number to each written character, may it be a letter, number, punctuation, etc. These assigned numbers are usually stored and transmitted in binary, ones and zeros. Now, one could ask, why transmit in binary? Think back to the Morse code example. How many possible signal lengths were there? 2, a dot and a dash. Why were there only 2? What would have happened if there were 26 lengths, one for each letter of the alphabet? Then we would only need to send one signal for each letter, right? But thinking about your experience in class, how much harder would it be to make sure you were holding down the button for the right amount of time, or for the receiver to hear the difference between the different lengths? The easiest way to avoid misunderstanding is for there to be a few options for each signal as possible, which is why Morse code uses only 2 lengths, and why in computing we use binary, which only uses 2 digits, a 1 or a 0. Now, another reason we want as little ambiguity as possible is that we want to send messages as fast as possible. How fast data is transferred is called the data rate. The higher the data rate, the less amount of time you have to distinguish between two values. If my dots are 1 second long and my dashes are 3 seconds long, those are easier to tell apart, but the message will take longer. On the other hand, if my dots are 1/10 of a second and my dashes are 3/10 of a second, then I can transfer data faster, but it is harder to tell the difference between the two. It's the same when it comes to computers. A faster data requires more precise encoding and decoding in order to be accurate. At high speeds, such precise messages often require that the sender and receiver are using the same unit of time to know how frequently to measure the voltage on the wire, and to know how to split it into bits. In the USB protocol, and this would be an exercise in your homework assignment, each message always starts with a clock synchronization that allows the sender to specify how long each bit is going to be. This concludes our lecture for today. Make sure to watch the lecture video on addressing and message framing. Thank you and have a good day.